first example. Here we have a quadratic equation because we see this x squared. It is not yet in the form ax squared plus bx plus c equals 0. And so our first step is to subtract 1 on both sides. Hopefully you're already familiar with the quadratic equation with real valued solutions. If you are not, this would be a good time to go watch the video on that because there's going to be some assumed knowledge you have on the quadratic equation already. Here we have the quadratic equation in the right form, and so now we need to say our a is 2, our b is 4, and our c is 7. And we're going to use the quadratic formula with those values. The quadratic formula is, of course, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And once we have it like this, we need to simplify. We need to multiply out 2 times 2. The denominator will now be 4. The negative 4 cannot be simplified. This radical is usually the hardest thing to simplify. There's a lot of stuff going on here, and I'm going to go ahead and simplify that off to the side. So we've got square root of 4 squared is 16. Negative 4, this is a negative 4 times 2 is negative 8. Negative 8 times 7 is negative 56. And 16 minus 56 is negative 40. Now, here we're going to notice that we have the square root of a negative. And for that, we should think to ourselves, if you haven't already seen imaginary numbers, we're going to take a brief dive into it, although we won't go into some of the properties of imaginary numbers. That's for a different lesson. Let's talk about the imaginary number I. I is the square root of negative 1. And the reason this is imaginary is because we're asking what number times itself will give us negative 1. And we know that a positive number times a positive number is a positive, and a negative number times a negative number is also a positive. And so there isn't any real numbers that can multiply together to multiply by itself to get you a negative 1, because both negatives and positives multiply by themselves to get positive numbers. So whenever we have the square root of a negative, any of these square roots of negatives, we will have an imaginary number. The imaginary number I is specifically the square root of negative 1. It is the number that when you square it makes negative 1. Okay, but just having this single imaginary number, the square root of negative 1, that's what I is, it's the specific imaginary number that is the square root of negative 1, allows us to deal with all other imaginary numbers quite easily. For instance, the square root of negative 9 can be found by breaking this up into the square root of 9 times the square root of negative 1, and the square root of 9 can be simplified into 3, and the square root of negative 1, we've said, is the definition of I, and so this is 3 times the imaginary number I, which we'll write as 3i. So 3 times I, just like we'd write 3x, as it means 3 times x. So we can take any square root of a negative and break it up. We'll do one more example here. This can be broken up into the square root of 12 times the square root of negative 1. And the square root of 12 can actually be simplified even more because we can find a perfect square number that goes into it. The square root of 12 can be broken up into the square root of 4 times the square root of 3, because 4 times 3 is 12. And the square root of negative 1 is I. And the square root of 4 can be simplified here. This is 2 times the square root of 3 times I. And we will, there are actually two kind of common ways to write this. It's fine to write 2 square root of 3i. Another form of writing it that some people like is 2i times the square root of 3. Either way, I'm okay with. So hopefully we feel good about simplifying square roots with square roots of negatives. Whenever we have the square root of a negative number, we'll end up with an imaginary number. And in fact, this brings us to the idea of when we're dealing with the quadratic formula, which hopefully you remember still. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There is this part under the radical, b squared minus 4ac, has a special name. It's called the discriminant. And the word discriminant is related to discriminate, and it doesn't mean anything bad here. It just means we're able to separate into two categories. If The discriminant, if d is at least equal to 0, greater than or equal to 0, so it's 0 or a positive number, the solutions to the quadratic equation will be real, and that's because we'll be doing the square root of a positive number or 0, and so those will have real square roots. But if d is less than 0, and another way of thinking about that is d is negative, then the solutions will be imaginary, and that's because we'll be having the square root of a negative number. So, with these two things in mind, going back to our example, we had just started simplifying this square root and we had gotten to square root of negative 40. The negative 40 is our discriminant here, and this is less than 0. It's a negative number, and so we will have imaginary solutions. Let's work on how to split this up. Hopefully you feel comfortable doing it yourself. The square root of negative 40, I'm going to break up into the square root of 40 times the square root of negative 1. This is our trick to make it into a positive square root and make use of the imaginary number I. The square root of 40 can be simplified some because we can find a perfect square number that goes into this and break it up into square root of 4 times square root of 10. And this is helpful because we can do the square root of 4. The square root of 4 is 2. The square root of 10 cannot be simplified, and the square root of negative 1 was I. So this whole square root simplifies into 2 square root of 10 I. Cool. And we do want to make sure we can't simplify it at all. This can be simplified into a easier fraction because we'll notice that both the numerator and the denominator have a common factor of 2. We've got 4, 2 square root of 10i, and 4. And so we're going to divide both the numerator and the denominator by 2. So we're going to divide by 2 over 2, which is a fancy way of dividing by 1. When we divide the numerator by 2, we have a binomial. Negative 4 is one term, and 2 square root of 10i is the other term. And so when we divide by 2 over 2, we will get negative 4 divided by 2 is negative 2, plus or minus. Here, 2 square root of 10i divided by 2 is just 1 square root of 10i. We won't write the 1 in front. And the denominator divided by 2 is 2. Notice we don't divide inside the square root, we're just dividing the coefficient. And so if this 2 hadn't been there, this would not be a factor of 2, and we would not be allowed to divide by 2. It's only because the 4, the 2, and the 4 all had a factor of 2 that allowed us to divide here. And this is our simplified answer. These are the solutions. These are the possible values of x. They are imaginary. And if you plug them back into the original x values and use some of your skills on simplifying imaginary and complex numbers, it'll work out to be equal to 1. It will make a true equation. One thing I'd like to point out is that this is not an imaginary number. We would call this a complex number. It's neither real nor imaginary, but when we're talking about quadratic equations, we're comfortable saying quadratic solutions that are not real. We'll call them imaginary solutions, even though this is not an imaginary number, it's a complex number, which you may or may not have learned yet, but we'll call this an imaginary solution even just because it has this I in it. That's good enough for us to call it an imaginary solution, even though this isn't exactly an imaginary number. All right, let's do one more example together just to make sure we feel good about it. I'll let you walk me through these steps. And the first thing we should recognize is that this is a quadratic equation, and it's not equal to 0, so we need to subtract 5x from both sides. X squared plus 9 equals 0. I notice that a is equal to 1 because there's 1x squared here. There is no x squared, and no x term, and so b is equal to 0. There are 0 x's, and c is equal to 9. So once we've got that, we can write out the quadratic formula. It's going to be negative b. I'm going to write negative 0 here, although sometimes we can skip this and just write the plus or minus sign and be comfortable with it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so these are going to be the values of x that make this equation true. And let's simplify the radical off to the side here. So we've got square root of 0 squared is 0. Negative 4 times 1 is negative 4, and negative 4 times 9 is negative 36. 0 minus 36 is negative 36, and we can see right away that the discriminant is the number that's inside the square root. Notice that the discriminant doesn't have the square root with it, it's just the number inside of the square root, and that is less than 0. And so this will be have imaginary solutions. When it has imaginary solutions, we will break this up into the square root of 36 times the square root of negative 1. And the square root of 36 is a perfect square root. We can evaluate the square root of 36. 6 times 6 is 36. And we can evaluate the square root of negative 1. That's the imaginary number I. So this whole square root becomes 6i. Negative 0 is just 0, and 0 plus anything is itself, and 0 minus anything is the negative of something. And this is why a lot of times when b is 0, we won't write it, because this is just going to end up being plus or minus. We don't need to write the 0 here because the 0 won't have any effect. Plus or minus 6i divided by 2 times 1 is 2. And we can divide this. There's only one term. And so we get x equals plus or minus 3i. In this case, plus or minus is a positive or negative sign. And we're saying that x could equal, the plus or minus means that x could equal positive 3i and negative 3i. Those are the two solutions for x. And unlike before, I think I'm going to go ahead and plug this in to check it. I think our skills are probably good enough right now to see, does this make the equation true? And I could choose either one of them. I'm going to choose the positive 3i to check, and I could check both of them. And I'm going to plug this in for x to see, does it make this equation true? So when x is 3i, I'm claiming that it makes this equation true. So 3i is going to be substituted in for x here, and we're going to get 3i squared plus 5 times 3i plus 9 equals 5 times 3i. 3i squared means 3i times another 3i. 5 times 3i is 15i. 9 equals 15i. 5 times 3i is 15i. And we can multiply 3i times 3i. We can multiply in any order we want. Just like if we were multiplying 3x times 3x, that would be 9x squared. 3i times 3i is going to be 9i squared. I'm going to subtract 15i on both sides. And so that will be 0. So plus 9 equals 0. And finally, we need to know this trick for imaginary numbers, that I squared. We defined it earlier. We said I was the imaginary number that is the square root of negative 1. The square root of negative 1 is I. And so I is the number that when you square it gives you negative 1. So when you square I, this is going to be negative 1. So this is 9 times negative 1, which is negative 9, plus 9 equals 0, and that is true. So 3i is the number that when you plug it in and simplify, which took some work here, took some work to simplify it. When we plug it in and simplify, we will get a true equation. All right, hopefully you're feeling good about your quadratic equations with imaginary numbers.